tolerance. But that's, yeah, as I said, you're taking a big guess still, because of all the other factors that might impact survival. We ready to go? Going back to the little um, medusae that actually is swimming around after it got released by the Millepora colony. Wait, I got it. So this was we were. I have to be honest. We did a lot of dives to figure this out, and we weren't able to find anything. Um, and at a certain point, we resorted to having a tank with ripe Millepora colonies and a full crate of Amstel Bright and a picnic table. And within 5 minutes, we were like, "What's happening there?" And they came out. But the question is, how further? Because we want to narrow down these spawning times locally and regionally, because we want to utilize them for these restoration efforts and maybe even select also on thermal tolerance. Um, and that's where I asked the divers in this group or snorkelers, like, if you see anything like these goosebumps, the ampullae on these fire corals, please take a picture and date and location, and you can send them through to me. Because we do not know that much. Even us looking at them for 2 years already, we haven't been able to narrow down the exact time of spawning. So we're on it, but um, we 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 have, I don't want to say no clue, because we figured out when they are released in ex situ, but we still want to know this in situ. And once we have narrowed those spawning dynamics down, we can actually start looking at the settlement dynamics and how to use them for sexual propagation. And then comes, I think, a really cool part of this research project, of the firewall project. This is where it all started, actually. Well, a good friend of mine, Dr. Valerie Chamberlain, she looked at these big Porites beds that were growing at the Sea Aquarium around the reef at Sea Aquarium at Curacao. And everywhere in between those Porites beds, the club-tip finger coral, there's Millepora blades. And usually when you see these Porites, they are rather small. They don't really have the ability to grow, because their branches grow out and they break off. But when they grow within these fire coral blades, they have some sturdiness. They can grow up, because the blades will hold them on both sides. And I think the same counts for the fire coral as well. They can grow up as well, because on both sides there's these Porites beds. So the idea came from that, like, how are we going to use the asexual propagation and the sexual propagation of scleractinian corals, because those are the major reef builders. How are we going to elevate that by using these Millepores? So we started these outplanting experiments inside and outside of Millepores, and we actually found a really big difference. We use cement plugs. These are all different genotypes as well, so don't do that. If you outplant them, use the same genotypes, but for the sake of experiment, we use the different genotypes. And you can actually see how the fire coral grows around it. These are healthy, the coral plugs, and you can see how much they have grown, right? And this is about 3-4 months in. But it's small. It's like the plugs are 2.5 centimeters, but it shows you how the survivorship of these corals is actually incredibly improved by these fire corals. Because 10 centimeters apart from this, we had an outside treatment, and the few exceptions aside, they all look like this. They're all dead. And you can ask yourself whether, these are still there, but there's also a few that are dislodged. And we actually already, by propagating them in the nurseries, figure out that the parrotfish came out and they just nipped them off. And that's for small corals can be a bottleneck when you are not protected by fire coral. Suddenly you get eaten from the reef, and it can be anything really. But also the communities, the benthic communities on the outside of the fire coral plot. This is at the end, and it actually, like 2 weeks before we took this picture, the benthic community started changing. It was mostly turf algae, and Alwyn said before already, these algae are killing the corals. And all these corals died off, whilst their neighbors, and it's 10 centimeters apart, like that's this much distance, within the fire coral, are thriving. And yeah, you can see the comparison here, and we have a whole bunch of these pictures, and they all actually show the same.
Where is the fire coral in the first picture?
Yeah, it's a bit darker, but you see here the P-pore C15, it's here, but I think due to the picture it's darker. Yeah, it is definitely the same coral. I'm not faking you. However, for all these interactions, there's a time and place, because we also see these fire corals sometimes growing over these parietes, and especially in the in-treatments where these parietes are either not doing well, the fire coral is quickly already taking over and it grows over it. So you need healthy specimens to be outplanted within there. And oftentimes you also see when there is predation on you see here, there's predation on the coral heads, and the fire coral is like, hey, that's a nice little space to start growing over, and they take over. But we've also have a lot of examples where the parietes is actually touching the fire coral, and the fire coral is touching the parietes, and they're like doing totally fine. There's no negative interactions happening there. Usually when looking at elkhorn, the elkhorn is stronger than the fire coral. You can see this big lip like growing over the fire coral, it's shading it. And yeah, like most of the interactions we see are like this. However, then this neighborhood interaction comes into place again. The Coralliophila. Coralliophila means lover of coral. It's a ferocious snail actually munching on the soft tissue of corals. And one of these individuals, if they are big, they can eat 9 square centimeters a day. So if you have your little baby coral growing there and you have a bunch of these on there, it can be gone within a few weeks. But what we started noticing actually is that they also grow on these edges between the fire coral and the Acropora, giving the fire coral the opportunity to start growing over the Acropora. And this is one of those nuances that it's like it's not just two corals competing. There's a whole bunch of other factors actually influencing this. And that brings me to this example. We have been looking at a lot of fire coral colonies, right? Like I've been looking and trying to figure out what's happening here. And we started noticing all these white spots. And like something is eating it, or like what's going on this reef? And sometimes it would get really bad, like almost one side of the blade was almost fully gone. So startled, right? Like, what's happening here? Is it a disease, or what's going on? And then we actually figured out that it's a yellow-tailed damselfish. And they are pretty good at removing the live tissue of these fire coral blades. because they only do this in summertime. Because what do they do? The male damselfish have their territory. I don't know, the divers under you like have probably had an interaction with damselfish. They bite you. They are not afraid. They will chase a whale away from their territory. But they clean this whole blade of Millepora, and the females in the neighborhood, they don't have as much of a territory as the males do, and they start swimming around. And the male actually shows them like, hey, look at this nice little piece of artwork I made. And they invite the female, and they have multiple nests of different stages of eggs in development on these blades. So it's really cool. And this is one of those examples. But the more and more we started looking at these interactions, we actually figured out that it's not only these yellow-tailed damselfish, because also the long-fin damselfish, you see it here hovering above 2 nests on a Millepora colony. It's also the dusky damselfish, but they, like you see it, smaller damselfish, they do less damage to the overall colony. The yellow-tailed damselfish are definitely having a larger impact. And this is the bicolor damselfish, which is way smaller, and it only takes there's a fly in my eye now. It only takes a little part of the Millepora colony. And why do these observations matter? Because they influence your restoration outcomes. Because it makes you think about when and where to outplant, because this is one of the in-treatments I was talking about before. And it's fully covered with algae. All the corals are dead. And we were like, what's happening here? But there was a damselfish that decided, like, this is going to be my territory now. And within the one time point, 2 weeks, between those time points, all the healthy corals were gone. And they were overgrown by algae, because a damselfish decided, this is my territory, and I'm going to farm my algae here. And another thing why we should be concerned about this is an invasive algae, Ramicrusta. This algae actually has the ability to kill the fire coral by releasing some toxins. But it needs a way in, right? Because if this is just fire coral, that algae won't start growing. Maybe here, but that doesn't happen too often. If there is one of these damselfish that creates a hole in this fire coral blade, this algae gets the chance to actually settle on there, start growing, and start proliferating on these blades. And then I get to my concluding remarks. Even snorkeling, diving, whatever, even thinking about it, but get underwater and start looking at these neighborhood dynamics and start to figure out what's going on there. And that's also one of the things I want to do tomorrow on the dive for the people that are interested. Like, we're gonna outplant some of the coral colonies we use to collect larvae from for the kids project on Friday. So we're actually gonna show them how these little corals can swim around still. And read the stories from elsewhere, but also do not be shy. Like, share these observations that you have made and talk about them, and think about how to make restoration more easy. Because if you have observed something already and you have seen this, why not talk about it? And that's coming back to this Curacao-Ceiba difference, right? I've been out on this reef and I thought, like, oh, I know what's happening. I had no clue. And then if you start talking with people about what's happening here, then it starts to make more sense, and then you can elevate your knowledge on the reef as well if you talk with each other about that. And yeah, try to find those neighborhood dynamics. Try to figure out who's helping who and who's not helping who. And yeah, that's my presentation, and I really want to thank you, all of you, for being here tonight. Any questions?
So the damselfish actually haven't worked out a balance between killing off the coral that gives them protection and
So-
nurseries for the next year or something.
Mm-hmm.
They're quite happy. They'll just move on, will they, to another area?
Do I have to repeat it still, you think, or not? Okay. So these damselfish have not figured out the balance between like killing your coral and having a terratorium site for next year. Am I right? Yeah. So that's a really good question, actually, and I have to tell you that I do not know this exact answer. What we have observed is that they also use dead blades of fire coral. We had a lot of mortality last year, and they also make their territories on dead fire coral. But it's a bit different than other damselfish that we have in the area, because they mainly farm algae, and they use these algae as a food source, and they kill coral for that. And with that, they actually influence, especially our Acropora cervicornis, the staghorn outplants. They actually influence the health of these corals, because killing a coral gives a space for pathogens to come in as well. And these algae give space for the little ferocious snails to get in and start eating those corals. So the main thing with these damselfish is that most of the predators around the Caribbean, and especially in the southern Caribbean, are fished away. So these damselfish are allowed to proliferate. And what we see on our staghorn outplants now is that there are so many, and you cannot swim over it before like you get pulled here and pulled there. I actually had a cool project with one of my interns last year, looking at the influence of our outplants on cleaning stations. Because there's all around the reef, there's these little cleaning stations, mostly on boulder corals, with shark nose gobies on them. And these shark nose gobies, they actually present themselves there like a hair salon, and everyone comes there and gets this nice treatment of getting rid of all these parasites. And by placing our outplants next to these cleaning stations, there's one thing that happens with that, and that's those damselfish that make their little territory around it, right? So we looked at the influence of those damselfish by chasing away all the other fish on these cleaning stations, because these cleaners, most of them live from the parasites they eat from the fish. And we still do not have the data back, because that was quite a big data set. We had to film for an hour and then get everything into the laptop. We're still working on it, but I'm very curious whether they actually have a bad influence on the clientele that comes to these cleaning stations.
Can fire coral asexually reproduce? And if so, are you planning on putting it in a nursery?
So fire coral can definitely asexually reproduce. So I wish I had a picture of that here. That would make more sense. But if you have these blades, they really start growing out. And at these tips, they actually start growing small blades. And when there is big wave events, they break off and they fall. And there are some papers that describe actually this whole downhill part of a reef is all the same genotype. Just because it like starts breaking, it gets with the waves, starts growing again. And with that, they actually are very, very capable of asexual reproduction. We have some in the nurseries right now. We also have tried some experiments with them growing. And one of the cool things, we actually found out that the blade spacing, we put them in cement. The blade spacing between those blades does matter because they start growing, sheeting out over the cement. And the closer, there's this equilibrium of like how close you are and what's too close. But the closer they are, the quicker they hit each other. And again, because it's the same genotype, they start growing into each other. And within like 2 months, you have this plaquette of fire coral, which is, nothing is going to get in between there. But if you put one blade of fire coral there, there's algae in between there. Everything is starting to actually affect the single blades that you put in there. But if you put them close enough together, they create this barrier, really.
Thank you.
Cool.
Let's hear it for Lars.
Thank you, guys.
Thank you, Lars. Thank you, everybody, for coming. Make sure you pay your bill. Support our sponsors. Stay for dinner. And we're going to... does anyone want to dive? Did you talk to Emily? Join us tomorrow? Call in sick to work? Come on. Okay, then we will see you Friday at Liam's Cuisine for Kimberly and learning more about turtles. Thank you, everybody.